My name's Dr. Kim Baldwin. I was born and raised here in California. I did my master's, my PhD, taught, and have been a research associate at the University of the West Indies in Barbados, Sermes. I moved there in 2001. So I've been there a few years. Really, my background, for those of you that don't know, is I'm a marine biologist, ecologist. Actually, this picture here is me doing my master's research in Barbados in Oistins, which was with fisheries, pot fisheries in Barbados, looking at alternative trap designs and also working. This is where I really started getting into socioeconomics and understanding local knowledge of fishermen to improve the design of these traps. So really my background is in environmental mapping, environmental monitoring, conducting environmental impact assessments. I have a long history doing research in Barbados, but across the Caribbean. My background is very strong as well in GIS and marine spatial planning, as well as participatory research and engaging stakeholders in environmental management, monitoring, and data collection. So the foundation of my approach, my PhD, and much work that I've done over the last 20 years in the region revolves around this participatory GIS approach. It's really an approach. It is a user-centered, demand-driven way of obtaining and creating more comprehensive environmental information from a range of stakeholders. So participatory means everybody that knows anything, whether you are a government agency, a nonprofit, a community group, the public, etc. Every person in any ecosystem has information, knowledge, and a role to play in environmental management. The reason why this is important, a lot of times we get a better data product, right? We are getting more information, but really that ownership and the widespread collaboration and support, to me, that process is more important. This is where I really love, is by engaging people and showing people the information and the knowledge that they have that many times they don't even know. It empowers them to actually become more active in environmental management and working together to come up with collaborative solutions to our problems and issues. Why are we going to use drones for agriculture? Cost effective, high resolution, on-demand data that we're going to be able to get in 3D, but it's going to allow us to capture, quickly act, and then analyze data. And we're going to go over this, and we're going to develop crop monitoring strategies over the course of the 2 months. So agricultural applications, we are going to be learning about all of these. We're going to learn how to use drones for crop health monitoring. We're going to look at plant emergence. We're going to use drones to understand more about precision agriculture and improving planning in terms of planting and resources and how to site maybe certain crops. Some crops, I know cotton in particular, it grows only at certain slopes, certain rainfall, certain elevations. We're going to be able to utilize drones and geospatial technologies to precisely plan and develop agricultural and national food security. We're going to use drone technology and overlay the data in the maps with the irrigation patterns, with the elevation patterns, so that we can better understand water management. And we're going to also use it to basically, I'm going to introduce you to machine learning and automated tools and apps that will allow you to estimate the amount of crop harvest and when the yield optimization. So when is the ideal time? There's apps that will look at cane and tell you 89% of it's ready to harvest at this point. Oh no, it's only 75%. Rather than doing edge analysis and guessing, we're going to be able to use drones to have more quantitative data and indicators. So we're going to learn a lot about this and how we can apply this for weeds and pest management, planting, as I mentioned, longer term, potentially spraying, livestock. All right, understanding, I've worked with many ministries of agriculture and understanding the locations and the conditions of these animals and the food they're eating on, soil analysis, So NDVI, SAVI, the water, soil composition, and research and development with agriculture, as well as very quickly being able to assess and use apps and tools for crop damage assessments and reporting. So drones for disaster management. This is actually a drone shot that was just taken, unfortunately, about a month ago in Carriacou, and the devastation that happened in the Grenadines, which is somewhere that I've worked and I love very much. My PhD was based there. Being able to use drones for this real-time damage assessment, to be able, whether it's flooding or storm surge monitoring, search and rescue, as well as coastal vulnerability mapping and warning systems. As I mentioned, the benefits in terms of that remote communication, the real-time damage information, being able to monitor and inspect, as I mentioned with the Anguilla case, the landslide in 3D, being able to measure things in 3D, and to help use this information for mitigation and for how do we get in and successfully get into areas to help. And last but definitely not least, this is where we're going right now in the Grenadines, is using drones and geospatial data to quantify these damages and to really understand restoration efforts and where to focus our efforts. I think everyone's limited in resources. And so it's where's the worst affected areas so that we can focus in the right areas and prioritize correctly. In wrapping up here, what are you going to learn? This is a great example. This is exactly the kind of things that I want us to be doing. And this is where I want you to be thinking about your sites, whether they're the 3 sites that have been proposed, but we've got many more that we can do during this class. So this is an example from Duke's. They gave me this piece of paper and they want to redevelop this land. This is the only piece of paper that there is, the only type of map. And so I took that picture with my phone. I was able to import that picture into Drone Deploy to create the flight plan. All right. And so 105, 8 hectares only takes under an hour to complete. And then we were able to create this orthomosaic map of Duke's Farm, which was then exported and shared with the BAMC via Google Earth because they don't use ArcGIS or Drone Deploy. All right. We're going to learn how to use something called Live Map, which is amazing. So without cell data, you're going to be able to go up and you're going to watch the drone fly in real time. And as it's flying, it starts stitching this map in the air. So when you land, you've got a map that you can go and ground truth and do in-field measurements without even leaving the site. This is one of my favorite things about this software, is this ability to annotate and do measurements within the field, to be able to draw points and lines and even take pictures with your iPad in the field that are geo-referenced. So when you go back to the office, the things you saw at certain locations, you can have ground-based shots stitched on top of your drone imagery. Here's just another great, I just wanted to get you excited here, right? Mount Brevitor, St. Peter. This is just showing the orthomosaic and some of the different products we're going to get, okay? So here's an elevation surface. We're going to learn how to make 3D models and use this to improve farm management. All right, we're going to learn how to use even to understand plant health variability and changes. This is showing a compare tool, changes over time here on the right. But this one is just showing that we are going to be able to turn on certain filters to look at the normal picture, but also the plant health variability. This one here is showing NDVI. But we're also going to learn, even with the Air 2S, a regular RGB camera, there are tools that we can use to identify the variability or the dead versus living areas very quickly that can help us ground truth and spot check things very quickly. All right, this is another one. What we're going to have to spend a lot of time in this class doing, and this is going to be very, let's say, crop specific. Don't worry, Barbados Fisheries Division, we've got lots of fishery stuff too we're going to work on. I'm just focusing a little on ag today, is understanding field indicators. What I'm going to need, as I am not an agronomist, I've done a bit of work in the last 4 or 5 years with various agronomists though. But here's examples from Barbados is understanding field indicators, understanding what do you all do on the ground right now? How do you know when to do certain field actions or monitoring or harvest? It's a lot of times it might be when the pigeon peas are flowering. After they're flowering, that's when they're ready for harvest, or once the flowers disappear. I'm making up things right now, but understanding field indicators, and then we're going to learn which tools we can use in the drone software to quickly identify what kind of flight plans need to happen. And more importantly, which most people don't realize, is drones don't just answer everything for you. You still need to do boots on the ground. Almost all drone surveys, land, sea, agriculture, sargassum, whatever, require typically some sort of quick field survey to ground truth and to check and validate the accuracy of the results of the drones. So this class will also be integrating bits of that into it so that you can understand how this process works. We will be working on various demonstration sites, but you will have an approach and a methodology that you will be able to use your head and be able to, you're going to know the workflow and the methodology that you could reapply it to any type of case study once I'm finished with you in the next couple months. So again, I think I showed this to the team a few weeks ago, mapping emergence, understanding, like I said, we had to measure the height to understand what, let's say, height to fly the drones at. And then we use these tools to identify the emergence. And I also showed we're going to learn how to use these types of tools once you fly an area. So for cane, understanding the height of cane is critical to understand when to harvest. So we're going to be able to draw lines to measure, let's say, a distance or an area. But if you see here, we're also getting the slope, and we're going to be able to understand the vertical height. So this cane's really on average only about a ½ meter high at this point. We're going to use these tools also to quickly identify problems, all right? So maybe there's pests or flooding or weeds, and we're going to learn how to use these to either ground truth and get back to these areas, but also to understand indicators for management action. We're going to also get an introduction to automated analysis and the integration of AI and machine learning. And this field has been blowing up in the last 6 to 9 months. The drone teams that did my classes a year or two ago, these ag teams, would be so jealous right now because things have really changed. So we're going to learn how to use, this is called a stand count, where basically offline you land, and for certain crops it will automatically look at the image and count. You can see here the red dots here on the right is where it automatically counted the crops, and then it's showing you where there's gaps and problems so that you can identify what action needs. Does it need to be replowed? Could it just be hand replanted? Does it need to be sprayed, etc.? So we're going to touch onto these tools as well. We cannot go deep into these tools because we've got a lot packed into this class. And as I mentioned, we're going to learn how to create issue reports to flag problems and report things and create automated reports. This is another great example from the Bahamas. They just created this. I just printed it yesterday, you can see, but they created this in May or June of this year. This is an agricultural area, one of the largest areas in New Providence, called Cowpen Road. And they were able for the first time in this class to understand and quantify all of the lots, the areas, and ground truth it to understand which crops were growing where. So we will be creating and working on things like this. So this actually was replicated again from one of those piece of paper maps they rolled out for me first week of class. And it was a big map that was a hand-drawn map from who knows when. It was all tattered and torn. And we imported that and we used that to recreate and create a now electronic map and quantify the amount of areas of the holdings, as well as identify the crop types. And as you can see here, other infrastructure. So it is a disaster risk management map, a habitat map, space use map, and also it's got threats, problems, and issues mapped here as well. So then we will also learn how this data can be exported out and integrated with other software. This specifically is showing you in Wakefield how we integrated it with ArcGIS. So participatory mapping, we will, as I touched on this, work, and this class is not going to be able to go too deep on this, but once you create the drone information, going back to the farmers, to the fishers, to the resource users, to community groups, and working with them, showing them these maps and integrating their local knowledge into these maps and into the geospatial data. This has a two-way benefit. One, the product, as I mentioned, but the process, engaging them and getting them to understand what we're doing, why we're doing it, and have them collaboratively come up with solutions is really where this gets exciting.